Right, in question 4, relative to a fixed origin O, the point A has position vector I minus 3j plus 2k, and the point B has this position vector. And they lie in a straight line. And the first thing we've got to find is AB. Well, AB, I'm going to convert these into into column vectors because I find it much easier to work with. You take the vector from O to B, which is minus 2, 2, and minus 1, so that's the I, the j, the k part, minus the vector OA. So it's 1, minus 3, 2. You basically take the position vector of A away from the position vector of B to find AB. If you think about that diagrammatically, there's A, there's B, and there's the origin. So the position vector of A, the position vector of B. The reason why we take away A is because we're going to go that way down AO, and then we're going to go along here to OB. So that's minus OA. So hence we end up taking away the position vector of A. And that gives us minus 2 minus 1 is minus 3, minus 2 minus minus 3 is 5, minus 1 minus 2 gives us minus 3. That's part A. Part B, we want to find the vector equation L. So we're going to find the vector which represents L. And this, the way we do this is going to be representing this line between A and B. It should be a straight line. Now what we need to do to find that is we need to first of all find a way of getting to the line. Now we can use either OA or we can use OB to find a way of getting to the line. And then we need to find a direction vector. Well, that is any vector in the line that is parallel to the line. In this case, AB is that vector. Okay, A to B is parallel to the line. So therefore, R will be how we get to the line. I'm going to use OA, which is 1 minus 3 minus 2. So 1 minus 3, 2. And I add to that some multiple of the direction vector. Minus 3, 5, minus 3. And you can use any parameter here you like to describe this. Now we're told, in the second part of the question, there is a point C that has position vector 2i plus pj minus 4k with respect to the origin, and p is a constant. And given that AC is perpendicular to L, find the value of p. So what do we have? We have A, we have C, sorry, that's B I want here. And this was our original line L, going through these points. And here's our origin. Here's our line L, A, B, and C, we get told that AC is perpendicular to the line. Now quite often you get asked to find a point that's perpendicular to the line. This has actually been made easier because we've been told it actually goes through AC, and we can find AC. And AC will equal C, which is 2p minus 4, minus our value of A, which was 1 minus 3, 2. So that would equal 1 away from 2 is 1. We've got p plus 3, and then we've got minus 4 minus 2 gives me minus 6. That gives me AC. And we know AB from the previous question. AB equals minus 3, 5, minus 3. Now we know that these must be at right angles to each other. So therefore their scalar product must be naught. So AC dot AB must equal 0. So this implies that 1 dot times minus 3 plus p plus 3 times 5, we're using the component form of the scalar product formula, and minus 3 times minus 6, which is 18, equals 0. And from this we can find p. So we've got minus 3 plus 5p plus 15 plus 18 equals 0. And therefore 5p will equal minus 30. So p equals minus 6. Now we need to find the distance of AC. Well, we know that AC will equal 1 p plus 3 minus 6. So it's 1 p plus 3 is minus 3, and we've got minus 6. And we want to find the length of that, which is just the square root of 1 squared plus minus 3 squared plus minus 6 all squared, which is the square root of 1 plus 9 plus 36, which equals root 46. Let's just go back and check how the answer wanted to be written. No particular way, this will do fine.